Hello, everybody. Today, I can use Newton's law of heating and cooling by carefully substituting in values and solving exponential equations by taking the log of both sides. Let's get right into it. We're going to jump right to number 3 because this incorporates basically everything you need. It's going to tell you the formula. It's going to tell you what each variable represents. Ideally, most of the time, it'll literally lay it out like this, which is even better, but it might tell you within the problem like it is here in number 2. Either way, it will tell it to you, so just read carefully to see what's going on here. But here it says TA is the temperature surrounding the object, T0 is the initial temperature, little t is the time in hours, big T without a subscript is the temperature after time passes, and K is a decay constant. So we're going to carefully read through it and identify what each variable is and go from there. After sitting out of the refrigerator for a while, a turkey at room temperature, 68 degrees, is placed into an oven at 8 a.m. when the oven temperature is 325. So there's a lot to digest right there from that one sentence. The turkey is at room temperature. It's starting at room temperature. So the initial temperature of the object is 68. It's put into an oven where the oven temperature is 325. So it's sitting in an oven. The temperature surrounding the object is 325. You have to be very careful of this. If it's a law of cooling problem and it's sitting out at room temperature, the temperature surrounding the object would be 68, would be the room temperature. So you have to kind of read carefully and see where the object is. In this case, the object is in the oven, so the surrounding temperature is 325. If I had taken it out of the oven and it was sitting at room temperature, then the temperature surrounding the object would be 68. So you have to just be careful and read what's going on. All right. Now, I didn't use this 8 a.m. yet, so I'm gonna kind of circle it. I'm sure I'll have to come back to that at some point, but that is not any of those variables, at least not directly. Next sentence. Newton's law of heating explains that the temperature of the turkey will increase proportionally to the difference between the temperature of the turkey and the temperature of the oven as given by the formula below. A lot of words, no numbers, nothing important. The whole sentence is garbage. That's nothing. We don't need anything from that sentence. It didn't tell us to do anything. It didn't give us any important information. It's saying there's a formula. I already knew that because I saw it earlier. All right, now again, we're going to go one sentence at a time. The turkey reaches the temperature of approximately 100 degrees after 2 hours. So let's stop right there. 100 degrees after 2 hours. So the temperature of the turkey is capital T. That's the temperature of the object. That's 100 after 2 hours. So little t, the time that passes, is 2 hours. Find the value of K to the nearest thousandth. All right, so it's finally telling us to do something. I have values for all the other variables, and K is what I'm trying to find. So I'm going to carefully substitute into this formula. Capital T is 100 equals TA is 325 plus T0 is 68 minus TA is 325. E is E. Negative KT, negative is negative, K is what I'm trying to find, and T is 2. So that's me carefully substituting my values in. Organize the information like this, even if it's a problem where it's not laid out like that, either way, list it like that, so it'll be easier for you to substitute in. So now I need to solve for K to the nearest thousandth. So this is an exponential equation. I'm going to combine what's in the parentheses first. 68 minus 325. 68 minus 325 is negative 257. So I can just make this into minus 257. E to the negative 2K. To solve an exponential equation, I need to isolate the base and I need to log or ln both sides. So I need to get the E by itself. I always add or subtract first. I see a minus here, so I'm going to subtract 325, subtract 325. That's negative 225 equals negative 257 e to the negative 2k. I'm not isolated yet because I have a negative 257 in front. I divide both sides by negative 257. So I've got negative 225 over negative 257. You can leave it as that for now, 225 over 257. You can make it into a decimal, it doesn't matter. Equals e to the negative 2k. And now that I'm isolated, I take the log of both sides. We spoke about that with e, it's easier to do ln of both sides. It doesn't matter. You can do log of both sides. I'm going to do ln of both sides. So I have ln of 225 over 257 equals ln e to the negative 2k. The reason I do that is the exponent comes to the front, and ln e is 1. It just goes away. If you did log of both sides, then you'd have log e. Now I'm one step from the end. I divide both sides by negative 2, divide by negative 2. I go to my calculator. I've got alpha x ln, which is on the left-hand side, of 225 over 257 over negative 2. I got 0.066. So k equals 0.066. So I did all that. I found k. Great. However, there's another question. Now it says determine the Fahrenheit temperature of the turkey at 3 p.m. So now this second question has nothing to do with this 100 and this 2. It has to do with the information that it gave me. Now it's talking about 3 p.m. So the temperature surrounding the object is still 325. The initial temperature of the object is still 68. The time in hours is not 2. At 3 p.m., well, I started at 8 a.m. I went from 8 a.m. to 3 p.m. How many hours is it in the oven for? Well, that's 7. So now T is 7. Oh, that's too yellow. T, the temperature of the object, that's what it's asking for. It wants to know what the temperature will be. So again, the second question has nothing to do with the first question, so this is T. And now I know that K is 0.066. This one's a little bit easier to solve because I'm not going to have to do any algebra. I'm going to carefully substitute in. So T is T. TA is 325 plus T0 is 68 minus 325. E to the negative. K is 0.066. I found that in the first part of the problem. And T is 7. I'm not solving for anything in the exponent. I'm solving for T, which is by itself already. So this question is much easier. Some of the questions in this lesson, you're going to have to do the whole exponential equation twice. But this one, not. 325 plus 68 minus 325. E is second ln to the negative 0.066 times 7. I'm looking at it to make sure it's right. It looks good. To the nearest degree, 163 degrees. So for these Newton's law of heating and cooling, they're going to give you the formula. They're going to give you what each thing represents. If they don't lay it out nicely like that, lay it out nicely yourself. Carefully substitute in. If you're solving for something in the exponent, you have to solve the exponential equation, which is a separate lesson, which we already learned, which is isolate the base and then take the log or ln of both sides. With e, it's easier to do ln, but you don't have to. It doesn't really matter at this level. Once you solve that, you have k. If it asks a follow question, you replace k with what you just found. And understand that the second question is not related to the first. So for the second question, this information is gone. I'm not doing anything with that information. I use that information to find k. I'm not going to go over another one. You can refer to the answer key as needed. They're all the same. Sometimes it'll give you k. It's not going to always ask for the same thing, but they'll usually ask for either k or t. So carefully substitute the values in, isolate, and then solve the exponential equation by isolating the base, taking the log or ln of both sides. Read it carefully. The math itself is the same math that we did in solving exponential equations, just reading carefully. That's it. I've done enough. Practice this. You need to do a few of these. It's going to be a 6-point question on the regions, and it's not hard if you're prepared for it. Goodbye.